Hello everyone, welcome to MITS Digital Learning Platform. I'm Mr. Seshu Kumar, working as an assistant professor in the Department of Computer Application, Madanpalli Institute of Engineering and Technology, Madanpalli, Andhra Pradesh. So in the series of lectures, first we are starting a programming world. We are starting to the programming world, that is Java. So in the series of lectures, we are going to learn the complete programming knowledge, and this complete online platform is related to excel the student knowledge to either to work on the applications related to the industry standards as well as academics also. So in today's session, first we are trying to concentrate the concepts related to Java virtual machine, as well as the memories which are related to the JVM. Okay. So in today's content, first we are trying to discuss the introduction part of JVM. That means we have to discuss what is a virtual machine and what are the other virtual machines available in the market, and then how the JVM really works. That's we have to focus on it, and then we have to discuss about the bytecode. The reason already we have the object code. Now why we have to learn the bytecode and what is the importance of bytecode, that we have to focus on it. And later on we have to completely concentrate on today's session, that is JVM, Java Virtual Machine modules, as well as different kinds of components of JVM also. So in today's session, first completely we can concentrate on this session. So welcome to the digital learning platform. So first of all, we have to discuss about the basic idea about JVM. Before entering into the concept of JVM, that means a Java virtual machine, because JVM stands for Java virtual machine. So before entering into this concept, first we have to understand that what are the different virtual machines are available in the market. We have system related virtual machines as well as the application or process related virtual machine. Generally, virtual machine is like an emulation. It provides some infrastructures where your Java code is running. Okay, we can also say that it is like a runtime environment. Okay, now this Java virtual machine is like a simulation to your application that to execute the bytecode. Okay, for example, generally in runtime environment, if you are observing that Java programs run and operate on multiple devices in the market, right? Because if you are trying to create any Java application, it has to run on multiple devices which are available in the market. And one thing is, if you are coming for object code, that means if you are coming for machine level code, the problem is whenever you are trying to execute the code, it should be platform dependent. That means, for example, let's assume that if I try to run a C programming, once if you are compiling and if you are running with the object code, now it is highly not possible, because once if the code is running on a Windows operating system, it should not be compatible with Macintosh operating system or Linux operating system. That is the main important drawback of procedure-oriented programming languages. So to overcome this problem, what Java people are suggested that whenever we are compiling the Java code, whenever we are compiling a Java code, we are getting a bytecode. I will discuss what is meant by bytecode, everything. So once if you are getting the bytecode, now this bytecode is the input to the JVM. Okay, that is, it is an integral part of Java runtime environment for platform dependent in nature, which means that all the JVMs available in the market. Okay, for example, as I said that we have either system related virtual machines or process related virtual machines. This JVM is comes under the category of process related virtual machines. For example, not only in our Java, if you are moving for other environments like Python, also we have for bytecode running, we have Python virtual machine, and some other vendors also they are providing. For example, Oracle is providing Hotspot, right? This is a Java hotspot. This is also considered as a virtual machine. Now coming to, if you are focusing on system related applications, system related virtual machines, in the sense if you are going for VMware. Okay, VMware is a software. It's a kind of software that will provide the infrastructures or the runtime environment for the operating system itself. Okay, so this is about a small introduction part. Now we have to completely focusing on how the JVM will work. So before understanding about the JVM functionality, first we have to understand the main important slogan of Java, right? What are the slogan of Java is simply nothing but, once if you are writing, you can run anywhere the Java application. That is, Java applications are referred to as Aura applications. Write once, run anywhere. Java programs we can write Java code on one platform and expect to work on all Java enabled systems. That is the very important part of JVM, very important part of JVM. The point here is you have to understand that once if you are running any Java code, that means once if you are compiling any Java source code, we are capable of running that source code. That means we are capable of running that .class file on any platform. Okay, either it may be supported on Windows operating system, it may be supported on Macintosh or Linux, etc. Okay, so the JVM, whenever your source code is compiled, for example, let's assume that I'm having test.demo.java file. Okay, so either by using any type of editor, I can compile using the compilation command like javac file name.java, then we are getting the .class file. Okay, now this .class file is the input to the JVM because this .class file contains bytecode. Okay, now what the Java is doing? Now the JVM is performing some kinds of instructions to load this .class file into the environment. It will go for loading of the .class file and then verifying the .class file codes, and then it will execute and it will provide some runtime environment support for the execution using memories. Okay, so we can see all the things. So before that, first we have to concentrate on what is the bytecode. Okay, because in normal programming languages, we are working with the object code, right? Nothing but whenever we are compiling source code, we are getting object code, nothing but to convert for the machine level. But whereas in Java or as well as in Python, the bytecode, whenever we are compiling the source code, we are getting the bytecode because this is the very important instruction set for the JVM. The point here you have to be noted that the JVM is always taking the input from the .class file. That means .class file's semi-symbolic code is nothing but the input to the bytecode. So we have different definitions for the bytecode. So let's see one by one. Okay. So bytecode, we can simply say that it is a semi-symbolic code. Sir, what is the meaning of semi-symbolic code? Generally, if you are observing any object level code, otherwise if you are observing completely any machine code, it should be either in zeros and ones. Once if you are compiling with C or C++. But here, a semi-symbolic code is simply nothing but the combination of source code along with some literals and along with some symbols. So we can simply say that bytecode is like a semi-symbolic code. I will try to show you in next coming sessions. Once if I'm compiling the .java file, I may be getting the .class file which contains the set of complete bytecode instructions. Okay, and we can also say that the main important objective of bytecode is simply nothing but it is the instruction set for the Java virtual machine. That means JVM is always try to reading the instructions from the .class file, but not source code. Now we have a small doubt, sir. Why we are using the concept of bytecode here? It's very important. That is, bytecode is completely platform independent. Bytecode is completely platform independent. That means once if you are generating the bytecode, it may be available for running of the applications in any one of the platform. Okay, it is not at all depends on a particular platform. Now we can also construct the definition that bytecode is an intermediate representation of your Java source code because it is not purely source code. Again, it is not purely object code, nothing but machine level code. It is an intermediate form of source code as well as machine code. So we can say that bytecode is an intermediate representation of your source code which can be executed by the JVM. And of course, we can also say that JVM is providing the runtime environment, right? It provides the infrastructures to the runtime environment. Now, the main objective of bytecode is, as we discussed, that to make the applications are completely platform independent. Okay. Now, point here is you have to remember from this content, you have to remember only one point, that bytecode is a semi-symbolic instruction set for the JVM. Bytecode is semi-symbolic instruction set for the JVM. As well as you can also concentrate that what about the part of JVM? That means is for all the different environments, the JVM is common. The question is, remember that point. Bytecode is independent. Okay, that means anywhere we can run. Java applications are independent, but JVM is platform dependent. Sir, what is the meaning of it? For example, let's assume that I'm thinking that JVM is like a model. Okay, I'm thinking that JVM is like a model. Okay, one of the company, they are providing the model and they are delivering this model to the world. Okay. Now let's assume that I'm the provider, nothing but I'm the implementation provider like Oracle. Now, based on this model, I can implement my own algorithms to the JVM. Okay. So which means that now Oracle company is the provider to provide a different algorithm. That means its own algorithm for the model of JVM. Not only for the Oracle, if you are taking for any companies, all the companies, they may be creating their own model for the JVM. I will try to discuss with the same example also. For example, let's assume that I'm having one smartphone. I'm having one mobile phone which is provided by the Samsung company. This is like a model. Okay, now as a customer provider, I may be using any different type of algorithm. That means any type of network. I may be using Airtel, I may be using Vodafone, I may be using Idea SIM, anything. Okay, so this is about a bytecode introduction. Now let's see how the general bytecode will be executed. This concept is very, very important. So try to focus on it. Let's assume that in real world, what happens in general? In real world, either programmers or students or learners, they have to write source code, right? First, how they will be write? They're simply taking any kind of editors, either it may be Notepad or basic editor like Notepad, Notepad++. Otherwise, they may be using any IDEs, integrated development environments like NetBeans or Eclipse. Now, finally, they're developing the source code. So everyone knows that for every programming file, you have to follow the respective extension. If it is a C, or you can be saving with the .c. If it is a C++, you can maybe saving with a C++. If it is a Python programming, you can go for py. And if it is a Java programming, you can save the program with the .java. Okay. So now the programmer is ready the source code hello.java. Now, based on this diagram, I can represent that every execution part of Java program is divided into two phases. Okay, we can simply say that the first phase is like the first phase is like that generating of bytecode. That is, whenever the source code hello.java is compiling with respect to Java compiler, now we are getting the bytecode, nothing but the dot class file. Okay, so I can simply say that compiling of the bytecode is like phase one. Okay, phase one. Now what happens here? Whenever you are compiling, instead of generating the object code, it is generating the bytecode. A small point here, I have to remind to you that if your source code contain n number of dot class files, then n number of classes, Java classes, then n number of dot class files will be generated by the compiler. Clear? For example, in my class hello.java file, I'm having only one class, so one dot class file is produced. For example, if your file contains n number of Java classes, then ultimately n number of dot class files will be produced. Okay, keep remember this point. Now I'm getting this hello.class file which contains bytecode. Now, as I said, as I discussed in earlier slides, that now observe this bytecode should be the input to the JVM, right? Now I'm having three kinds of JVMs here. Either it may be in Windows platform running, or it may be a dependent platform of Linux JVM, or it may be a dependent platform of Macintosh operating system JVM. So what the point here you have to understand now? Here you have to understand that JVM is platform dependent. Remember, JVM is platform dependent because provider will customize the JVM as per his recommendations. Okay, so JVM is completely platform dependent, but the bytecode what you are executed, what you are trying to execute with platform independent. Of course, even in many of the interview cases also, their students may get stuck or may get confused at that which is independent, which is not independent. Remember that bytecode is completely independent, JVM is completely dependent on vendor. Okay, that means on service provider, right? Now observe, this hello.class file is executed by different JVMs. Now finally I'm getting machine code. So I can consider that this is a phase 2. Okay, so at the time of execution of the bytecode enters into, in general, two phases. Phase 1 is from source code to compilation, then it turns to dot class file, phase 1. Phase 2 is now we have to pass this code to the JVM to generate the machine code. Now this machine code should be understand from the operating system. This machine code should be running by the operating system. Okay. Now in Java platform, for the compilation, generally we are using Java C command. And for the running prompt, we are using simply Java command. Okay. Now, first we have to understand that now you are in a position that the dot class file should be reading by the JVM. Now it will generate the machine code. Now the machine code should be understood by the operating system. Now the question is, what inside the JVM? What inside the JVM? Okay, it is a virtual machine, right? It is a virtual machine. It is an abstract machine. It is providing the simulation of the application, because check it out that I can also construct that definition that JVM is providing runtime infrastructures to the bytecode. Sir, how it is? Observe. The dot class file always inputting to the class loader subsystem, because I can, first of all, I will give you a glance about the modules of JVM architecture. We can simply say that the entire JVM architecture is divided into three modules. Okay, module one is class loader subsystem, where it is responsible to take all the dot class files and it will go for the next steps. And here it is concentrating on how to load the dot class file, how to verify, and how to execute everything. Each and every step is carry forwarding by this class loader subsystem. Now, uh, again, the JVM architecture is divided into some separate runtime data area. We can also say that the second module in the JVM, that is memory areas. We have 5 different kinds of memory areas, like class area or method area, both are same. And then heap, nothing but like a dynamic memory area. And then stack area, Java stack memory area. Now we have PC registers, program counter registers, and then native method stack. Okay, so the second module is very, very crucial in the JVM architecture, because for the execution of the bytecode and assigning the memory areas to the bytecode should be happen in this runtime data memory areas. Okay, now apart from this, the third module we are having the complete execution engine. This execution engine is simply nothing but it contains interpreter as well as JIT compiler, and then it also contains some native method libraries and native method interfaces to interact with the compiler, and it has to get the information from the standard API packages of Java. Now, once if the dot class file enters, it enters into different cases, and then finally it should be understanding by the operating system. Okay, now we have to completely focus on each and every component of this JVM architecture. So before going for the next slides, I request each and everyone, please try to take a diagram of it, either through screenshot. Now we have to focus on each and every one. Okay, so I will first of all, I will try to give you clear idea what is the main objective of each and every component of this module. The responsibility of class loader subsystem is loading the dot class file and going for the verification of the bytecode, whether the bytecode may be correct or whether the bytecode may be wrong. Okay, everything will be. Now, your source code may contain different parts of the instructions, right? If you are taking any Java class, the Java class may contain it may be contain functions, it may be contain static variable declaration, it may be contain instance members, and it may be contain constructors, everything. So we can simply say that a Java class is like a container which contains different varieties of elements. Now the question is, for example, if my Java class contains some methods, nothing but the functions. Now, where the function space will be allocated, or for static variables, etc. So, if you want to assign the space for class level data members, or if you want to space for the function declarations, it should be happened in the method area. We can also say that class area. Now, for all Java related class objects, we can simply say that runtime objects, Java objects, we are assigning heap memory using DMA allocation operator like new operator in Java. And then stack memory. The stack is completely responsible to allocate the frames for the invoking of the methods. We can also say that some local variable. That means if a method wants to execute, it requires some space, right? So the space should be allocated for the Java stack memory. Now, what is the current running instruction for the JVM? That should be discussed in PC registers. And finally, if you want to get any API documentation related native method information, then we have to go for one interface. Now, the third module is nothing but I want to execute each and every instruction of a bytecode. For that, we are using interpreter, and to optimize the performance of the bytecode, we are using JIT compiler, just in time compiler. Both are interacting with native method interface as well as Java interface libraries. Now, finally, this dot class file is converting after it has been undergone for the specifications of the module. Finally, it goes to the operating system for the execution part. Okay, so this is a complete glance about JVM architecture. Now we have to observe each and everything in very elaborative manner. Okay, so the first thing is the first thing in JVM architecture is nothing but what? Class loader subsystem. Okay, class loader subsystem, always the responsibility of class loader subsystem is always simply nothing but what? Loading the bytecode and applying for the verification. Okay, now at this point I will try to discuss one more point also. Generally we have different kinds of class loaders like bytecode verifier class loader or extension class loader, and we have system related class loader, everyone having their own different case. For example, if you are going for bytecode class loader, this bootstrap class loader, always this bootstrap class loader main responsibility is to load the libraries of standard Java development kit application. For example, either it may be loading for java.lang or java.utility, java.network slides, otherwise any machine instructions which related for the JVM, everything. Now if you are going for the next one like extension class loader in general, it should be loading all the instructions from the directories of extension folders inside the home or library folders like in JRE format. And the last one is nothing but what? The system related class loader is completely responsible to load the JRE files inside the class path. Okay, that is a different story. If you want to go for any infrastructures development related to class loader, you have to focus on it. Now come back to the discussion of this class loader subsystem. The main important responsibility of this class loader subsystem, first of all, the class loader subsystem loads the dot class files into the memory. Now the questions are what kinds of memories we have, we will discuss. Okay, so first responsibility of this dot class file is what? Class loader subsystem is, it is loading the bytecode into the memory. Now immediately once if the loading is completed, then immediately it will go for verification part. Okay, for example, then the next step is simply nothing but it will go for the bytecode verifier, which is verifying whether the bytecode instructions are properly framed or not. For example, if it finds any suspicious instructions, then immediately the execution process will be terminated. Automatically it is rejected. For example, if the instruction codes are in a very proper format, then only it allots the necessary memory to execute the program. Okay, so this complete class loader subsystem is taking the responsibility of examining the bytecode. Again, I'm repeating what the main important class loader subsystem objective or functionality is simply nothing but what? It is completely examine the bytecode. If the bytecode is properly framed, then it allocates the memory in the next module. Otherwise, it simply removes the entire bytecode. Nothing but it completely rejected. Okay. So the next part in the modules is the memory part. Is it right? So what is meant by the memory part here? Try to observe. So the entire Java memory is completely defines into 5 kinds of memories. Already we have seen. Among that, the first one is the class area or a method area. Sir, the question number 1, sir, why they may be named it like a class area? Because if you are taking any Java applications, it is constructed with respect to different classes, right? A Java code may contain one class or it may contain a number of classes. So the main important aspect of the class area is simply nothing but the block of memory that can store class related instructions. For example, a class, if you are taking, what is a class? A class is simply nothing but in Java, it is like a container or it's like a user defined data type. This user defined data type may contain different varieties of elements. It may contains variables, right? It may be static member or it may be instance member or it may be contain some functions. It may be contain some, again, it may be contain some inner classes. Again, it may be contain the body for the constructors, everything, right? So this class method area represents always, it will store the exact definition or it will store the places for the class methods. Okay, for example, if a class contain 2 or 3 methods, let's assume the case that if it contains 2 or 3 methods, first of all, they require some space to execute, right? So this class area is a memory space where it will provide the storage for the class code. It may be a normal method, or it may be any static or different kinds of method, or it may be any static variable. Okay, it may be any methods of other Java programs. So everything will be available under this class area. Now, the second very important part of the second memory space is simply nothing but the heap memory. In general, let's check the case that in my Java application, I may contain static related data, nothing but class related data members, or non-static related data, right? That means which are very frequent, which are related to the objects. For example, if you want to access any class data, we require objects. That is the main important concept of an object-oriented programming. Is it right? So, if you are trying to create a variable for the class, definitely you have to create the objects. It may be a runtime object, right? Because the objects in Java, how you can create, simply you can create the objects like class name, object name is equals to new of constructor call as a class name, right? Here the main important role which is carried out by the new operator is very important. If you are moving for C programming, for the dynamic memory allocation, you are using either malloc function or memory allocation functions, calloc function, malloc function, etc. But here we don't have any calloc, malloc function. Instead of that, for the heap memory allocation, we are using an operator called new operator in Java. New. This new, technically we can call it as a DMA operator, dynamically memory allocation operator, which will provide the memory at runtime to the objects which are created for the class. Okay, so this heap memory is completely responsible to allocate the memory space for the objects which are created at runtime. Hope you're understanding the point, right? For example, I'm creating 5 objects for the class, then all 5 objects will get the memory space at heap memory area. Okay, so the second case is simply nothing but what? Heap memory space. Now, apart from that, we are also having the next memory space, that is stack memory. So this is for very important memory space, because consider the case that I'm trying to execute the method. Definitely method wants to invoke something from other procedures, is it right? Because at the runtime, method maybe gets executed and it is invoking other methods, or it may be taking the variables or input from the other from the keyboard or etc. Is it right? So at the time of method is executing, that is, if method during the execution part, it requires some more memory to store the data and their results. Is it right? So try to examine each and every source code first. We are having one Java class. For the Java class, I'm assigning class area, right? That means the instructions of the class. Now, whenever a method try to get invoke some other methods, a method is trying to execute the other methods. Now, what happens? Now that method has to take some extra space. Now that space, we can simply call it as the stack memory area. So simply, a stack is like a temporary memory space for working of the method calls, or for other data variables. Like for example, consider that I'm trying to iterate a loop using a method call. It may be 10 times or it may be some n times. So for each and every execution, the method should be recalling the old variable value, nothing but local variable value. Now the question is where the local variable value should be available. The local variable value or the buffer memory space for the local variable values will be available under stack. Okay, so the point here, you should remember that stack is a memory area for the execution part of the methods which are available under class memory area. Okay, so we have to glance on it, check it out. Java stacks are the memory areas where Java methods will be executed in each time a method gets called. For example, now the question is, okay, for example, if inside my class, if a method m1 is called, then m1 method should be invoking to execute a loop. Okay, now for that loop, 10 times the instruction should be might be they have to be executed. Now the question is, sir, where the memory space is allocated? Now we have to we had a discussion that inside the stack, the memory space is allocated. Okay, fine. Now, where inside the stack, how the memory space is allocated. So that's point you have to remember. Whenever a new method call will be available inside the stack, automatically your JVM is taking the responsibility to create a memory block. That memory block, like a temporary memory block, the temporary memory block is, call it as a frame. Okay, call it as a frame. Even in operating system subject also, if you are trying to understanding the, if you are trying to understand the examining the RAM architecture, right? Random access memory, RAM is divided into, physical memory is divided into the frames, right? So in the similar sense, whenever a method required a memory space, automatically frame should be allocated for the method call. Frame should be allocated for the method call. Now method process will be completed, then automatically the frame is destroyed by the JVM itself. So point here you have to understand first. First of all, stack memory is available for local variables or temporary variables. Now each and every time whenever a method call should be executed, then automatically a JVM is taking the responsibility to create the a frame inside the RAM, right? Inside the random access memory. Now once if the purpose is completed, once if the execution part is done, then automatically the same frame which is created by the JVM is also be destroyed. Okay, so the JVM is always creating frames and destroying the frames by using the operating system interaction, like it may be the architecture of RAM, everything. Now apart from that, the question is, sir, how a method should be taking the frame inside the stack? The question is, we are using the concept of multi-threading, because each thread is associated with one frame. So the thread is responsible to execute that particular method. Okay, so automatically you are, whenever a process, a separate process or a thread is gets executed by a stack, then automatically a frame will be created, and once if the work is done, automatically the frame will be destroyed. Okay, right. Now we have to concentrate on next module, because till now we have to complete in the second module, that is we have to concentrate on class area, and then we have to concentrate on heap area. Okay, and then we have to concentrate on stack, what is stack, and how the stack frames will be created and destroyed. Now the next concept in the memory space in the second module of JVM, that is PC register, program counter register. You know, we have learned about operating system PCB structure, right? Process control block structure, where each and every time the currently executed instruction should be identified with the program counter in general, right? PC means program counter. So the same phenomenon here also. For example, JVM is executing the bytecode instructions up to m-1. Let's assume that each and every time the JVM is try to identifying the bytecode instruction. Now, at any point of time, if I want to find out that how many number of instructions, how many number of bytecode instructions are executed and how many number of bytecode instructions are left, that complete history is managed by this PC register. So what is a PC register? PC registers are those registers, nothing but the memory areas that can completely contain the memory address of the currently running JVM instructions. Okay, because after some time there may be a chance that if any high priority instruction is enter into the RAM, because of that maybe our JVM, the currently executing process, or enter into a waiting stage. So because that is a complete phenomenon of executing the operating system process by process and all. So JVM each and every time it has to monitoring the complete set of instructions, how many instructions got executed and how many are remaining. Everything should be completely maintained like a diary with the PC register. Okay, so PC register main important responsibility to identify how many instructions are executed and how many instructions are pending in the bytecode format by means of JVM. Now the last one is simply nothing but in the second module, that is native method stack. Stack is different, native method stack is different. Let's assume that, for example, at the time of Java application execution, okay, that means if a bytecode, if I'm trying to execute the bytecode, definitely it is sometimes it maybe depends on some standard libraries. That means nothing but native method libraries. For example, like java.lang, java.utilities, okay, some java.other API related packages, it has to focus on it. So this native method stack is simply nothing but it has to completely uh, completely focusing on the libraries, what it requires, from the documentation part. Either it may be sometimes it may be interacting with the native libraries, like it may be interacting with the C libraries, or sometimes it may be interacting with some other programming platform libraries. So at that time, inside the JVM, they're providing one stack that if our current running Java application bytecode wants to interacting with any other platform native method libraries, or inside the same Java documentation library, then at that time we are using native method stack. Okay, so this native method stack is always interconnected with the native method interface, which will supply the required code for the standard libraries of Java. Okay, so the second module, once if the second module is done, then we have to completely concentrate on the third very important module, that is execution engine. The third important module, that is execution engine. So what is an execution engine in general? Now the first level class loader is try to loading the complete bytecode. Is it right? Now once if the bytecode is completely verifying, then the class loader subsystem is allocating the memory space in the second module. Okay, like class area, heap area, then stack area, and so on. Now this execution part, this execution engine part is simply nothing but the main responsibility. It is try to converting your bytecode, which is available under .class file, into the machine code format, because the basic funda is always the platform, the operating system platform is try to understand only in the machine code, right? So the execution engine is always responsible to execute the instructions line by line, and to optimize the performance we are using compilers also. It's a combination, because see the diagram, inside the third module we have two sub modules will be there, right? One is interpreter, second one is JIT compiler. We can simply say that this JIT compiler is like a just in time compiler. JIT compiler stands for what? Just in time compiler. You have a small doubt, sir. You are using the combination of interpreter and compiler in this execution engine. Yes. Interpreter, general objective, general behavior is always it has to execute the instruction line by line, right? But what about the compiler? It has to execute all the instructions at a time, and it will display the error messages, if any, right? Why we are using the combination of interpreter as well as just-in-time compiler in the execution engine, in the sense we have to read the each and every instruction. Now to optimize the application performance, we are using just-in-time compiler. Okay. Now what are their main important responsibilities? Simply nothing but they are converting the bytecode instructions into machine code, so that only the processor can execute them, right? Whatever the operating system required processor will be there, they have to be execute the machine code instructions. So in Java, JVM implementation is very important point. You have to remember that in Java, the JVM implementation using both interpreter as well as just-in-time compiler, nothing but JIT compiler, simultaneously to convert the bytecode into the machine code. Okay, simultaneously this process to be happen until and unless your .class file will be completely executing all the instructions. Now this technique is called adaptive optimizer. So this adaptive optimization is simply nothing but to improve the process of the application of Java. The reason, if I'm trying to execute each and every line only with respect to the interpreter, then it may be impact on the performance, right? So to overcome that problem, we are using JIT compiler, just-in-time compiler, to optimize the performance of the Java application. Okay, Java application. So I hope you can enjoy the session. So if you want to give any your feedbacks are highly appreciated. If you want to give any feedbacks, now these are the following references of my slides. Now if you want to give any feedback, you can kindly give your feedback in this one. Now thank you. Signing off. I hope you are enjoying the session. I will continue the session in next classes. Thank you.